Hello guys, we are currently looking at Module 4, Homework A, Tab 4-Part 4. This is electric potential energy at launch point. So we are asked with calculating the electric potential energy denoted by capital U of the P at its initial position, which is at the origin of the semicircle charges. The P has charge lowercase q, and the semicircle has a total charge capital Q equals n times lowercase q, where capital N is the number of charges each of magnitude lowercase q, uniformly distributed along the semicircle of radius capital R. So the electric potential energy capital U can be equal to lowercase q times by uppercase V. And this is where Q is I've already said all that. So lowercase q is the charge of the particle, in this case the charge of the P. Capital V is the electric potential at the location of the charge due to the other charges. So from previous parts, we found that the electric potential capital V at the origin, the initial position of the P, due to the semicircle of the charge is going to be capital V is equal to K times lowercase k times uppercase Q divided by capital R, where K is going to be Coulomb's constant. Capital Q is equal to capital N times lowercase q, which is the total charge on the semicircle, and R is the radius of the semicircle, which is also the distance from the origin to any charge of the semicircle. So now to find the electrical potential of the P at the origin, we simply multiply the charge of the P, lowercase q, by the electrical potential capital V at the origin. So we're just going to get, again, literally this right here. And then we have to substitute V into that expression. So that's going to give us U is equal to lowercase q multiplied by lowercase k times uppercase Q, all divided by R. And that's going to be lowercase, remember, is the charge of the P. Capital Q equals to uppercase N times lowercase q is the total charge of the semicircle, and R is the radius of the semicircle. And that is going to be our final answer for this problem. I hope that helped.